I think this one needs a pen and paper for me to explain. So we have here series resistor R1 and R2. They are in series. The other one is in parallel. 100 ohms, 100 ohms parallel. This one is in series. Now let's start with this series resistor. Before we can calculate the I total, we still need first to get the total resistance of these two resistor. So the formula for getting the total resistance for series resistor is here. R total is equal to R1 R2. Easy, right? 100 plus 100 equals to 200. So if we simplify this circuit, this one is the simplified circuit. We just combine that two resistance, so 200, right? And we have now the volt total, we have the resistance total. Now we can calculate the current total that will be flowing in here. Now what's the calculator for current? Voltage divided by R. So 20 volts, which is this one, 20 volts divided by 200 ohms. Now we come up with this one. The I total is 0.1 ampere. That's the total current. Now in theory, if this is a closed circuit, the total current will be equal to IA, which is this one, and the one that goes out here, which is current IC, they will be equal. So the total current here will be 0.1 ampere. The IA, the current flowing to the 200 ohms, is equivalent to 0.1 ampere because this one is a closed circuit, right? The I total will be equal to IA and then IC here. Now that's the series resistor, how to get the current, right? So it says here, if we have to apply the 0.1 ampere here to here, so we have now 0.1 ampere. In theory, I said a while ago that total current is equal to IA and IC. So the current that will flow on R1 is equal to 0.1 ampere. Also here, 0.1 ampere. It will be the same, and whatever goes out here, it will be still the same, 0.1 ampere. So that's the correct current here, 0.1 ampere, 0.1 ampere. The current is 0.1 ampere. That would be very different if we are going to tackle parallel resistor. So before we can get the total current, we still need to get the total resistance of these two parallel resistor. And the formula for that is here. 1 divided by R total is equals to 1 divided by R1 plus 1 divided by R2, and so on. If there are multiple resistor, you can just add it in here. And now if we simplify this formula, we come up with this one. R total is equal to 100 times 100 because they are the same, 100 and 100. Then divide them by their total. So 10,000 is equal to 200. We come up with 50 ohms. That's the total resistance of this one if we combine them together. The simplified form of this circuit is here. 50 ohms, 20 volts. So we can now calculate the total current. Total current is equal to V total divided by R total. So this is the 20 volts, total voltage divided by 50 ohms. It says here, the total current is 0.4 ampere. So 0.4 ampere will be the current total, 0.4. Now, we again make this circuit into here because this one are the same. We just made these two resistor combined to each other, right? So that is being shown here, 50 ohms. Now we go back here. Now because we know the total resistance here, we also know the current total, which is 0.4 ampere, right? The current that will flow here to this resistor will be the half of this, so it would be 0.2 ampere, and here it would be 0.2 ampere. Imagine this is a water pipeline, water pipe. Whatever total water will be flowing in will be divided here and here, because this one is a junction, right? Now in theory, we already seen here that the current going here will be the same here. So I total, IA, IC is equal, right? Now if we go here, 0.2 goes out again here, 0.2, 0.2, and this one is like 0.2 again, right? Now they will be combined each other on this junction, thus we have the 0.4 ampere again. So that proves the theory that when you simplify this two resistor to be like this, right, it would be like 0.4 and then here 0.4. The same here. We are just showing here two resistors in parallel, but basically the total current going out will still be equal to 1 I total that is going in, or I mean going back. So 0.4 divided by 2 will be 0.2, 0.2, because they are the same resistance. If this one is 200 and this one is 100, the division of current will be differ. So if this one is 200, this one is 100, the current that will go here will be greater than what's go here. But because they have the same, the current will be just divided into 2. They will be divided into 2, right? And then go back again here, that they will be recombined. Thus, it comes again with 0.2 plus 0.2 equals 0.4. Now, the theory on here is still valid with this. So, that's how we should calculate the series resistor and the parallel resistor.